Hello everyone, welcome to lesson 1-4, properties of numbers. For this lesson, we're going to be learning about properties, certain rules or ways of doing math, and we identify them as properties. So identify and use properties of addition and multiplication. So a certain way or characteristics or features in the way we add and multiply, and use properties to simplify algebraic expression. For a real-world link, we have crafts. Duct tape has been used to create everything from flip-flops to prom dresses to wallets and homemade flotation devices. Algebraic properties can be used to find the amount of duct tape needed to make an item. So here we're going to see how we can use duct tape or algebraic expressions to determine different amounts. But before we do that, please make note of any of these pink sections. Okay, we have some descriptions I should say definitions, and over here we have the key concept of our lesson. So make sure you pause this and you write this down. You don't have to write it word for word in the definition, but make sure that you write something that you understand. In algebra, properties are statements that are true for any numbers. For example, the expression 30 plus 10 and 10 plus 30 have the same value. This illustrates the commutative property of addition. Commutative meaning to commute, to move around. So you can write 30 plus 10 or 10 plus 30, and they're both going to give you 40. So that's the commutative property of addition. Likewise, 30 times 10 and 10 times 30 have the same values, the same product of 300. This illustrates the commutative property of multiplication. So in multiplication and in addition, you can move the numbers around, the order of the numbers, and you're still going to get the same sum or the same product. Note that you cannot do that with division or subtraction. It only works with addition and multiplication. So the key concept: the order in which numbers are added or multiplied does not change the sum or the product. That's the best way to write it down. Symbols for any numbers, A or B, so A or B can be numbered. It can be A plus B is the same thing as B plus A. Or for numbers when being multiplied, A and B, for example, A times B is the same thing as B times A. Examples: 6 plus 9 or 9 plus 6, they both equal 15. 4 times 7 is 28, or 7 times 4 is 28. Now, just that we use commutative to commute, to move numbers around, we're going to use associative to associate or group numbers. To evaluate the expression 16 plus parentheses 14 plus 58, use mental math by grouping the numbers as 16 plus 14. The reason we would group these two is because they give us a nice round number. 10 plus 10 is 20, plus 6 and 4 is another 10, so it would be 30, or 16 plus 14 is 30, plus 58. Send 4 plus 6, you see here, the 4 and the 6, they make 10. So it would be 10 plus 10 plus 10. This illustrates the associative property of addition. There's also an associative property of multiplication, where we group numbers with parentheses, because we know when we do order of operation, we always do the parentheses first. And we want to make sure that we do the brackets or parentheses first. So we would rearrange them and put parentheses around the numbers that work well together. Words. The way in which numbers are grouped when added or multiplied does not change the sum or the product. For any numbers A and B, for example C, where we have A plus B plus C, you could regroup it and regroup the B and the C together as we've done here. For any numbers, for example C times A times B, it's the same thing as A times B times C. And we can just, here we group the A and B, but over here we group the B and C. So it doesn't really matter. Here's how we would do it with numbers. 3 plus 6 plus 1. Here you would do the 3 plus 6 first, right? Which would give you 9. Plus 1 is 10. Or if you did the 6 plus 1, as we've done here, 6 plus 1 is 7, plus 3 is also 10. So it will not change the value. It's simply a way to organize your process. What are you going to do first? 5 times 9 is 45, times 2 is 90. Or 9 times 2 is 18, times 5 is 90. And here's another key concept. Now, before you get overwhelmed by this large table, all I want to talk about is the word identity. We have additive identity for addition, and we have multiplicative identity for multiplication. Okay, and what we're talking about is that a number will not be changed. So let's say you have the number 5, as you see here. Okay, the number 5. We have 5 plus 0 is 5, or 0 plus 5 is 5. What we're saying is this number, the identity of this number is not being changed because we're adding 0. So the rule when adding 0 to a number, it doesn't change. The same happens with multiplication when you multiply a number by 1. If you multiply a number by 1, it's not going to change the number. Now, these rules may seem a little bit too obvious to you, but when we're actually working in algebra and you know that you have an answer and you later find out, or you have a product and you later find out that it has to be multiplied by 1, you'll know that it's not going to change your product, okay? And then there's the multiplicative and the property of 0, which means anytime you multiply a number by 0, it's going to be 0. 3 times 0 is 0. 0 by 3 times 3 is 0. Anytime you multiply a number by 0 is 0. Do these properties apply to subtraction and division? One way to find out is to look for a counterexample. A counterexample is an example that shows a statement is not true. So it will not work with division, it will not work with subtraction, but you can show a counterexample where you actually try it and you'll be able to prove that it's not true. Now here's example 1. Okay. Is division of whole numbers associative? If not, give a counterexample. So let's see, is it associative? Can we group them? So here we have, for example, 27 divided by 9 divided by 3. 27 divided by 9 is 3, and then 3 divided by 3 is 9. But what if I group them differently? What if instead of doing the 27 divided by 9, I knew the 9 divided by 3, as we've done here? 9 divided by 3 is 3, and 27 divided by 3 is 9. So they're not equal. You can see that. So division does not work with the associative property. Let's try it. Is subtraction of decimals associative? If not, give a counterexample. Okay, can we subtract decimals? So for example, I can have 7.1 minus 4.8 minus 1.2. And let's say I associate or I group these two first. When I do that, okay, I'm going to have 4.1, 2.3, right, minus 1.2. It's going to give me 1.1, right, 1.1. If I do the other one over here, I get 3.6 in the parentheses. 7.1 minus 3.6 is going to give me 3.5. So you can see that 1.1 does not equal 3.5, right? So no. My answer is no. Subtraction is not associative. Okay, now for example 2, we're going to actually be implementing some of these properties by completing these algebraic expressions or simplifying these algebraic expressions. Let's see here. Name the properties shown by each statement. We have 4 plus parentheses a plus 3 and a plus 3 again plus 4. Now again, we did not move the parentheses. It's still a plus 3 first, a plus 3 first. But we did put this in the beginning of the number sentence. So what have we done here? We've just changed the order. So this is the commutative property, okay, of addition. Over here, 1 times 3c is 3c. Whenever multiplying something by 1, it's not going to change the value, right? So this is multiplicative identity. You can see here, this is the multiplicative identity property. Okay, let's try and practice identifying these properties. Here we go. If you think you can do it on your own, please pause the video and try these 4 on your own. Pause now. 2a. D, any number, plus 0 is that number. It's D. D plus 0 equals D. What is this? Simply put, I write identity of and a plus sign of addition. Okay, let's try 2b. 8 times 1 is 8. We're multiplying. Does it change the value, the identity of the number, when you multiply by 1? No, it doesn't. So this is identity of multiplication. The x is for multiplication. Okay, let's try the next one. 2c. 14 plus parentheses 9 plus 10. Now, it's the same thing as parentheses 14 plus 9 plus 10. So here I'm going to do the parentheses first, where I get 9 plus 10 is 29, plus 14 is 43. Or I could do 14 plus 9, and let me write that down for you. 19 we said here, right? 19 plus 14, well, it's not 43, it's 33. And then over here, 14 plus 9 is 23, plus 10 is also 33. So it doesn't change the sum. So what is it? All we've done is just regroup the numbers. Here we group the 14 and the 9 together, and here we group the 9 and the 10 together. So this is associative property of addition. So associative of addition. And now let's try D. We have 5 times 7 times 2, or 7 times 2 times 7. Let's see what happens. 5 times 7 is 35, times 2 is 70. Right? And over here we have 5, I could do 5 times 2, or I can do 2 times 5, or 7 times 2 is 14, times 5 is also 70. So it doesn't change the product, but we did change the order, right? 5 times 7 times 2, or 7 times 2 times 5. What do we call this? We call it commutative of multiplication. Here's another pink section that we need to make note on. So simplify algebraic expression. To simplify an algebraic expression, perform all possible operations. You can use the properties you learned in this lesson. Using facts, properties, or rules to reach valid conclusions is called deductive reasoning. So use all the rules that you know to reach a conclusion. That's deductive reasoning. Okay, example 3 now. For this part, please be sure to look at the example. I'm only going to go over A, but I want you to pause and go over B, C, and D, because I want you to go ahead and look at all the different properties that have been used step by step. It is important that you show in this lesson every single step to show or prove that you understand how to implement all the different properties. So as you analyze these examples, pause and read each property that has been implemented. So let's see. For A, we have parentheses 3 plus E plus 7, right? 3 plus E plus 7 can be rewritten as E. So here we have, we first use commutative. Notice how we changed the order of the 3 and the E to E and 3, so that we put the 3 closer to the 7, because now we're going to use associative property and group these two. The reason we would group these two is because these two can work together. 3 plus 7 is 10. So we're just left with the E. So the simplest way to rewrite this expression is E plus 10. And once we know the value of E, we replace it and we solve. So go ahead and look at the multiplication, the addition, and the other multiplication problem. Take a minute to look at that. Please pause. Okay, if you feel comfortable now, go ahead and try 3A to D on your own, and make sure to use every step possible, or properties and rules that we know. Pause the video now. Okay, for A, I would the first thing I would do is I would associate them differently. I have 12 times 10 times Z. I would associate 12 times 10, so I can get 120 Z. That would be my answer. For 3B, I would look to first using commutative, right? So I'm just going to put C for commutative. I should have acknowledged that I did associative here simply by writing A, that I'm doing associative. Okay, over here I'm going to do commutative and move them around, because this 15, this 15 and this 16 will work together. So I'm just going to write W plus 15, close parentheses, plus 16, right? Now I'm going to use associative to regroup them, where I have W plus parentheses 15 plus 16, right? And now I get my answer is W plus 31. Okay, or 31 plus W. Now let's try C. C, I can do, anything multiplied times 0. Remember that? It's going to just simply be 0. So now that I've seen my entire line as it's all multiplication, and I'm going to multiply by 0, I know that this is multiplicative rule of 0. Or I should say not rule, but multiplicative property of 0. So I'm really just going to jump right to the answer and just write 0. There's no point in moving anything around. I could have moved it around and then multiply the 11 times the 0, but then that would give me 0 times b, and it's still 0. So you can just go right to the answer. And then finally D. I see that the 10 and the 18 can work together, so I will reorder it as P plus 18 plus 10, right? That's commutative, by the way. Commutative. Now I'm going to use associative and write P plus parentheses 18 plus 10, and now I have P plus 28, or you could say 28 plus P. They both work. Okay, have a look at our guided practice for class so that you feel comfortable starting class with these questions. See you then, everyone.